On Monday afternoon, a magnitude 6.1 earthquake struck off the western tip of Cuba, and millions of people across Florida felt the ground move for the first time in their lives, from Miami all the way to Tallahassee. It was the strongest earthquake the Gulf of Mexico has produced in 76 years, in a place that is not supposed to have them. By the end of this, you will know exactly why it happened, why you felt it hundreds of miles away, and whether the warning now spreading online is real. On Monday afternoon, June 8th, at 2 o'clock Eastern Time, a magnitude 6.1 earthquake struck beneath the southeastern Gulf of Mexico, about 104 kilometers off the western tip of Cuba. The United States Geological Survey first put it at magnitude 6.4, then revised it down to 6.1 as more data came in, which is routine for any large quake in its first minutes. The rupture happened roughly 26 kilometers down on what geologists call a reverse fault, near the town of Mantua in Cuba's far western province of Pinar del Rio. By the numbers alone, a magnitude 6 is not a monster. The planet produces one somewhere every few days. But this one did not happen somewhere the planet usually shakes. It happened in one of the quietest corners of the entire Caribbean, and it was felt by millions of people who have never felt an earthquake in their lives. That combination, an ordinary size in an extraordinary place, is the whole reason you are hearing about it. And it is the reason a single earthquake has turned into a national conversation. Here is what we can say for certain. This was the largest earthquake ever recorded by instruments anywhere in the Gulf of Mexico since at least 1950. In that entire span, more than 70 years, the whole Gulf has produced only about 6 earthquakes of magnitude 5 or greater. It was also the strongest quake within about 200 miles of this spot since the year 1880. There was no significant damage, there were no reported injuries, and the National Tsunami Warning Center quickly confirmed there was no tsunami threat to the Gulf Coast, the eastern United States, or eastern Canada. What there was, instead, was reach. The shaking crossed the Florida Straits and ran up the entire Florida peninsula. People reported it in Miami, in Tampa, across central Florida, and as far north as Jacksonville and Tallahassee, more than 400 miles from the epicenter. It was felt across the Gulf as well, in the Mexican resort cities of Cancun, Playa del Carmen, and Tulum. One rupture, off one quiet coast, registered across more than 1,000 kilometers of land and sea. For most of the people who felt it, the sensation was unfamiliar and unsettling rather than dangerous. In South Florida and around Miami, people described a slow, swaying, almost seasick motion, the kind of long, rolling wave you get when you are far from the source. Office workers watched hanging lights move and the water shiver in their glasses. Many people doubted their own senses at first and asked whoever was next to them whether they had felt it too. Calls and posts flooded local agencies within minutes. No one was hurt and nothing collapsed. But for millions of Americans, this was the first earthquake they had ever felt. And that fact alone turned a distant rupture into a moment they will not forget. So the first real question is simple. How does an earthquake off the coast of Cuba reach into living rooms across an American state where the ground is supposed to never move? The answer is the same thing that normally makes Florida safe. Florida does not produce earthquakes because it sits on a thick, cold, stable slab of ancient crust, far from any active fault. But that same kind of crust is a superb conductor of seismic energy. When a fault ruptures, it sends out waves, and how far those waves travel depends entirely on what they pass through. Old, solid, unbroken rock carries them for hundreds of miles with very little loss, the way a long steel rail carries the sound of a far-off train. Compare that to a place like California, where the crust is fractured and chewed up by thousands of faults. There, seismic energy gets scattered and absorbed quickly, so even a strong earthquake fades fast with distance. The stable interior of a continent does the opposite. It transmits. It rings like a bell when something hits its edge. That is why the Cuba quake was felt across so much of the southeastern United States, even though the energy arrived as a gentle, slow sway rather than a violent jolt. We have seen this before, and the comparison is worth knowing. In 2011, a magnitude 5.8 earthquake struck Mineral, Virginia, in the stable interior of the country. Because of that same efficient rock, It was felt by more people than any earthquake in United States history, across more than a dozen states and into Canada. It cracked the Washington Monument from more than 100 kilometers away. The Cuba quake worked exactly the same way. The ground that has protected Florida for millions of years is also a perfect messenger for somebody else's earthquake. That reach matters because of who was on the receiving end. When millions of people who have never felt an earthquake all feel one at the same moment, the shock is enormous, far larger than the physical event itself. The quake did almost no real harm, but it landed on a population with no mental category for it, and a frightened mind with no category goes looking for an explanation. That instinct is exactly where this story takes its strange turn. But before we get to the prediction now spreading online, we need to look at the part that genuinely puzzles the scientists, because this earthquake should not have happened here at all. Cuba is, geologically, two very different islands, wearing one name. The eastern end, near Santiago de Cuba, sits close to the boundary between the Caribbean and North American plates, and it has a long history of damaging earthquakes. If a magnitude 6 had struck eastern Cuba, it would have been news, but it would not have been a mystery. The western end, where this struck, is the quiet end. It sits well away from that plate boundary, behaving much more like the stable interior of a plate than its active edge. By every ordinary expectation, this is the part of the neighborhood that does not do this. The clue to why it happened anyway is in the type of faulting. This was a reverse fault, and that single detail is important. Some faults slide sideways, grinding past each other, like the San Andreas in California. A reverse fault is different. A reverse fault is compression, the crust being squeezed so hard that one block of rock is shoved up and over another. Over millions of years, that exact motion builds mountains. It is the signature of a place being actively crushed, and that raises a genuine scientific question. What, in a supposedly calm corner of the Gulf of Mexico, far from any major plate boundary, is doing the crushing? The most likely answer is that the rupture reactivated an old, buried fault, an ancient scar left over from the long geological assembly of Cuba itself. The island was built over tens of millions of years, as fragments of crust collided and stacked against the edge of North America, and that process left the crust laced with old compressional faults. Most of them have been locked and silent for an extraordinarily long time. But locked is not dead. These old faults can sit quietly for ages, slowly absorbing the strains of the wider planet, until one of them finally reaches its limit and slips. That is almost certainly what happened on Monday, after a silence of nearly 150 years. This is also why an earthquake here is so hard to anticipate. The loud, active plate boundaries get watched closely, because they shake often, and we know where they are. The quiet interior faults barely register in our instruments or our attention until one of them finally lets go. There is no dense network of seismometers blanketing the southeastern Gulf the way there is along the San Andreas, and the fault maps for this region are thin and uncertain. We are, in a real sense, underinformed about this corner of the world precisely because it has been so generous with its silence. The rarity is not a figure of speech. Remember, this was the strongest quake near western Cuba since 1880, and the largest in the whole Gulf in over 70 years. A region that produces an earthquake like this once in a century and a half is, by definition, barely watched and barely mapped, because the hazard has always seemed so low that the dense monitoring never seemed worth it. So when this quiet corner finally moved, the world felt it, named it, and immediately started looking for a reason. And the reason that spread fastest was not the patient grinding of an ancient fault. It was something far more frightening. Within an hour of the shaking, before the experts had even finalized the magnitude, a prediction began racing across the internet, and it was specific in a way that most fear is not. The claim, shared by enormous numbers of people, was this: a much larger earthquake is coming between the 10th and the 14th of June, on the eastern side of the Ring of Fire, the west coast of North America, anywhere from Mexico up through Alaska. The size given was enormous, a magnitude between 7.7 and 9.0, and the claim came with a hedge. If the big one does not arrive in that window, then the pressure is simply building toward an even larger release the following month. It is worth being fair to why this spread. The West Coast genuinely is one of the most earthquake-prone regions on Earth, and a large quake there is a real certainty on a long enough timeline. The prediction borrows the credibility of that true fact and staples a date to it. It also arrived in a week when the planet seemed restless. Just a day before the Cuba quake, a magnitude 7.8 earthquake had struck off the southern Philippines, on the western edge of that same ring of fire, killing dozens and sending a small tsunami ashore. Add the volcanoes that are always erupting somewhere on the Pacific Rim, and the human mind starts drawing lines between events that have nothing to do with each other. Look closely at how the prediction is built, because it is designed to be impossible to lose. It names a window, the 10th through the 14th, which sounds testable, but then it adds the escape hatch, that if nothing happens, the pressure is just building towards something larger next month. If a large quake strikes anywhere on the enormous West Coast in those few days, the prediction claims a hit. If nothing happens, it has already told you the big one is still coming. There is no result that can prove it wrong, and a claim that cannot be proven wrong is not a forecast. It is a way of being right no matter what. But notice what the prediction is actually claiming. It is treating the Cuba quake as a warning shot, the first tremor of a coming catastrophe thousands of miles away. And that specific claim, that one earthquake in the Gulf foretells a giant on the West Coast days later, is something we can actually test against the science. When you do, it falls apart completely. So let's do exactly that, because the truth here is more useful than the fear. The first thing to understand is the single most stubborn fact in all of earthquake science. Neither the United States Geological Survey nor any scientist anywhere in the world has ever predicted a major earthquake. Not the time, the place, and the size together narrowly enough to act on. They do not know how, and they do not expect to learn how anytime soon. That is not pessimism. It is the official position of the very agency whose job is to study earthquakes, and it has held through decades of effort by people who wanted nothing more than to prove it wrong. The reason is physics. A fault rupture appears to be a chaotic process, and the final size of an earthquake seems to be decided as it happens, by tiny details kilometers underground that we cannot see or measure. The rupture does not know when it starts, whether it will stop after a meter or run for hundreds of kilometers. Science can do real and valuable things. It can map where the danger is high, calculate the odds over decades, and send an early warning in the seconds after a rupture begins. What it cannot do is name a date. The viral prediction claims the one thing the entire field openly admits is impossible. Then there is the idea quietly underneath the prediction, the idea of a foreshock. Foreshocks are real. Sometimes a smaller quake does come before a larger one. The problem is that you can only call it a foreshock after the larger quake arrives. In the moment, a foreshock looks exactly like an ordinary earthquake. There is no signature, no flag, no warning label. And the statistics are brutal. Only about 5% of earthquakes turn out to be foreshocks to something bigger. The other 95% are the main event, and nothing larger follows. The overwhelming odds are that the Cuba quake was complete in itself. And even in that rare 5% of cases, there is a second problem that ends the prediction entirely. When a larger quake does follow a foreshock, it is almost always nearby, on the same fault system, within days. It is not a magnitude 9,000s of kilometers away on a completely different plate. The Cuba fault and the West Coast are not neighbors. They're not even on the same plate boundary. So the idea that a quake in the Gulf is a foreshock for California breaks the one rule foreshocks actually follow. But there is a bigger version of the claim, the belief that earthquakes are somehow connected across the whole planet. And that one deserves a real answer too. Earthquakes can influence each other. That part is true, and it is why this idea is worth taking seriously instead of just mocking. The question is how, and over what distance. There are two ways it happens, and the difference between them is everything. The first way is called static stress transfer, and it is the stronger and better understood of the two. When a fault ruptures, it physically rearranges the stress in the rock around it, loading some nearby faults closer to failure. This is real and measurable, and it is why aftershocks cluster around a big quake. But the key word is nearby. Static stress changes fall off extremely fast with distance, reaching only about as far as the length of the fault that broke, a few tens of kilometers at most. The Cuba fault could nudge its immediate neighbors in the Gulf. It could not reach California. The second way is called dynamic triggering, and it is the one that gives the prediction its sliver of plausibility. So let's be precise about it. As a quake's seismic waves roll outward, they can jostle a distant fault that was already loaded and ready, and tip it into slipping. This can happen at large distances. When the magnitude 7.3 Landers earthquake struck California in 1992, it set off tiny quakes as far away as Yellowstone. When the magnitude 7.9 Denali quake hit Alaska in 2002, it did the same thing. So distant triggering is real, but two facts about it dismantle the viral claim. First, dynamic triggering almost always sets off small earthquakes in places that were already primed and delicate, usually volcanic regions. It nudges the already trembling. It does not manufacture giants on the other side of the planet. Second, it takes enormous energy to do even that. Dynamic triggering is the domain of the truly great earthquakes, the magnitude 8s and 9s whose waves are still powerful after crossing the globe. The Cuba quake was a magnitude 6.1. Its waves had faded to a gentle sway by the time they reached Florida, a few hundred kilometers away. The idea that those same waves could cross an entire continent and trigger a magnitude 9 is not a small exaggeration. It is a violation of the physics. There is one more theory circulating, though, and it does not even involve faults. It reaches all the way to the Sunday. Some of the online discussion blames the Sunday. In early June, our star was active, firing off a powerful flare on June 3rd and driving a strong geomagnetic storm that hit Earth on June 5th. So the story writes itself. The sun erupts, the Earth is bombarded, and then the ground shakes. The problem is the energy. A geomagnetic storm interacts with our upper atmosphere and our magnetic field. It can disrupt satellites, stress power grids, and light up the aurora. The energy it actually delivers into a fault, 26 kilometers, underground, is so small compared to the forces that drive earthquakes that no physical mechanism has ever connected the two. When researchers have gone looking for a statistical link between solar activity and large earthquakes, they have found weak, inconsistent results, the kind of signal that appears in one study and vanishes in the next. There is no established mechanism and no reliable pattern. The sun was busy this week, and the Earth shook this week. For the same reason, both happen in many weeks. They are both active on their own schedules. The connection is in our heads, not in the data. So with the prediction, the foreshock idea, the triggering claim, and the solar theory all set aside, the only honest question left is what actually happens next. The most likely future is the quiet one. The Cuba fault will produce aftershocks for days and possibly weeks, smaller quakes clustered near the epicenter, fading over time in the predictable way aftershocks always do. Most will be too small to feel. That fading pattern is itself reassuring, because a normal sequence calms down, while the rare dangerous case sometimes does the opposite. The data so far shows ordinary decay, a fault settling, not winding up. And the window, the viral prediction named the 10th through the 14th, will almost certainly pass without a West Coast catastrophe, because there was never a mechanism connecting the two in the first place. There is a real lesson here, though, and it is not the one trending online. The genuine concern this quake exposes is not a countdown to a magnitude 9. It is that the Gulf and Caribbean margins, places treated as permanently safe, are under-monitored and under-prepared, precisely because they are usually quiet. Western Cuba just produced its strongest earthquake in nearly 150 years, and a region that rare is exactly the kind of place that is least ready when the rare day comes. Low probability is not zero probability, and the right response is not panic on a deadline. It is better mapping, better monitoring, and a steady seriousness about a real, if distant, risk. So here's what to watch. Watch the aftershocks fade, which is what the science expects. Watch the predictions window pass without the promised giant, and understand what really happened on Monday. A rare, powerful earthquake struck a place that almost never moves. It was felt by millions of Americans for the first time in their lives, and it carried no warning and no date. The ground is not sending us a message. It is doing what a living planet does, on a clock far longer than our own. We will be tracking the aftershock sequence as it develops, and if anything changes, you will hear it here first.